Hello everyone, welcome back to Math at School. In today's video, I'm going to show you how to solve this exponential equation problem using rules of exponents. Now, if you think you know how to solve this problem, then pause this video, solve this problem yourself, and put your answer in the comment section. I am going to reveal the correct answer in just minutes, so you can check whether you got this question right or not. Meanwhile, if you do not know how to approach this question, don't worry, I'm going to get started and solve this question right now. Now I have 3 raised to the power of 2x plus 1 divided by 3 raised to the power of 3x multiplied by 3 raised to the power of 4x minus 1 equal to 27. Now I am going to solve this part of the equation first, and then I'm going to multiply this second number to the first one, and then set it equal to 27 to simplify it, so that we can solve for the x in a convenient fashion. So let's take this part and solve this. Now I have 3 raised to the power of 2x plus 1 divided by 3 raised to the power of 3x. Now, since we have two numbers with same base, and we are dividing the first number with the second number, we are going to use the quotient rule among many rules of exponents that I have listed right here. So according to the quotient rule, if I divide a raised to the power of m with a raised to the power of n, the answer is a raised to the power of m minus n. So let's apply that to this problem at hand. The same base stays, and the exponent will be 2x plus 1 minus 3x. And if I solve that out, I get 2x minus 3x, which is negative x, and then plus 1 will remain. So I can replace this first fraction with 3 raised to the power of negative x plus 1. Now, the second step of this problem will be multiplying this 3 raised to the power of 4x minus 1 to this first number. So let's go ahead and multiply that number. Now, according to the product rule of my exponential rule of exponents, if I multiply a raised to the power of m with a raised to the power of n, I get a raised to the power of m plus n. So I can combine and have one base, and then I can add those exponents. So let's go ahead and do that. If I multiply these two numbers, I'll get one base, and then minus x plus 1 plus 4x minus 1. Now, let's solve that out. I am going to combine like terms. Negative x plus 4x, which is equal to what? 3x. Oopsie. 3 raised to the power of 3x. And then if I combine these two integer terms, they will cancel each other out and leave me nothing. So this left part of this equation, this part, can be replaced with this number, 3 raised to the power of 3x. Now that's equal to 27. Some of you might already know that 27 is composed of 3 multiplied 3 times. In other words, 3 to the power of 3. But for some of you who do not know that, you can always use factorization tree method to break down this 27 into prime numbers. Now, if you want to check out my method for building a factorization tree, then you can find the link in the description box. I'll leave a link to that. Meanwhile, I'm gonna build a factorization tree out of a number 27. That means I need to come up with two numbers that when multiplied gives me 27. So off the top of my head, 3 and 9 when multiplied together gives me 27. And I'm gonna circle a prime number when I see one. So 3 is a prime number. And if I circle this, this part of the tree is done. I'm not gonna branch out further. And 9, of course, is made up of 3 times 3. And since both numbers are prime, I circle and end the tree there. And I can rewrite it as, since there are 3 3's, 27 is equal to 3 cubed. So that's how I arrived at 3 cubed. And since that's equal to 3 raised to the power of 3x, what I can do is I can set these two numbers equal to each other, right? So 3x is equal to 3, and that means if I divide both sides with 3, that means my x will equal to 3 divided by 3, or 1. And that's how I would arrive at my final answer to this question. Alright, so that's how you would use these two rules, product and quotient rule of rules of exponents. And if you need more exercise, or if you feel like you want to see more video solutions pertaining these other rules of exponents, then you can visit my school on www.mathit.school, where you can access my worksheets as well as video tutorials to those worksheets in subject areas like these. So thanks you guys for listening. I am recording this after a long day at work, and I'm putting a lot of effort into this, so it would be really appreciated if you clicked that like button and also the subscribe button. Well, thanks for listening again, and I'll see you guys in another video. Bye!